Hello, hello, hello. Welcome back. It is Monday, the 11th of May, and today I'm doing paper 2 of the OCR B MEI series. I know I got a lot of positive feedback on the first one because apparently there's not a lot of stuff covering those papers. So I wanted to definitely cover at least one complete series so you have a full set. And I'm definitely looking forward to paper 3 because that just looks weird. So I'm going to go in completely sight unseen on that and just sort of find out what happens. So that could be very interesting when I do that next week. This is actually my second attempt to stream today. I went live like a few minutes ago, and like the second I went live, got a very important phone call I needed to take. I was like, all right, we're going to scrap this. We're going to try again. Now, have I slept well? No. Have I eaten yet? No. But today is going to go great because I am determined to put in a good showing. But it does mean that I'm probably just going to sort of race through. I might give a bit of commentary as we're going, but I don't think I'm going to be sort of like as chit-chatty, if that's okay. So without much further ado, I'm just going to jump straight into it. So, second screen. Do I want to set a timer? Nah, I'll be fine. So, all right. Right off the bat, question 1. Let me adjust the balance here so we get a bit more of the question. So we need to, for question 1, we have to calculate the exact distance between 2 points. That's fairly standard. All we have to do here is a bit of Pythagoras. So that is going to be the square root of the change in x, which is 6 minus 2, and the change in y, which is 1 minus minus 1. So it'll be square root of the change. It's 4 squared plus 2 squared. It's root 16. Could I do this on a calculator? Yes. Can I be bothered? No. So it's 2 root 5. Sweet. Question 2. The equation of a curve is this. We have a translation. So we have f of x basically is e to the x. This translation of 3 units to the right would make it f of x minus 3. And a stretch of scale factor 2 in the y-axis is 2f of that. So it would be 2 e to the x minus 3. Great. So it is just y equals 2 e to the x minus 3. Final answer. Question 3. Describe the shape of this distribution. I would say it has positive skew. Yeah, I'm not really, that's curious. So like, I've not seen a question asking like that in a while. So I'll be curious to see what they do in the mark scheme there. Now, I also know that I am notoriously bad at the wordy questions in math. So this is why we have mark schemes, but I could definitely show you how to do calculations. Total of 16 households, each spent between 60 and 65. And that's 3.2 times 5. So that makes sense. Determine how many households were in the sample altogether. Right. Well, all you need to know here is that frequency is represented by area. And frequency is equal to class width times frequency density. So the frequency density here is 3.2 times 5. And 3.2 times 5 gets the 16. Oop, sanitate. So that's where that 16 comes from. So here we have 0.5 times 10, so that's 5 people. Here we have 1.8 times 5, which gives us 9. Here we have 1.4 times 10 is 14. And here we have 0.2 times 20, which gives 4. So over here, 5 plus 16 plus 9 plus 14 plus 4 is... And this is the kind of, this is section A. I always tell people with exam technique, you got to be careful with the first question because the first questions you do set the tone, builds up confidence and momentum. For 2 marks, do I want to go on? I'll write out the full thing. So So the first questions really kind of set the tone of the paper and build that confidence and momentum. So one thing I do quite like about how these papers are structured is that the easy questions are right up front. So you do get that kind of sense of like, all right, I can do this. I can do this. Now, the potential downside of that is it could give you a false sense of complacency or not so much with your ability, but with the time. So it could be that you spend too much time on section A. That's just one of the things you'll pick up by doing lots and lots of papers. So here, sine 2 at, let me see. I think they want to make this. Okay, so let's make that pi over 2. So what's going to happen is the normal sine curve would have a period of 2 pi. So this one is going to have a period of pi. So if that's pi over 2 pi, okay. So this would normally be at pi, and that would be a pi over 2. So what's going to happen here instead is it's going to go up to 1, down to there, down to 1, and then to 0, to 1, to 0, to -1, to 0, where that would be at pi over 2. That would be at pi. That would be at 3 pi over 2. That would be at 2 pi. That would be 1. That would be -1. Great. And I won't bother putting in all of the max and min turning points. So then for B, a lot of people actually kind of struggle with this skill, I find. When you're doing these sorts of transformed trig equations, the very first thing you should do is to transform your interval. So I know I'm looking in the interval between 0 and 4 pi. And we're solving for sine of 2 theta is -1/2. So we can get the principal value for, okay, so making sure my calculator's in. Yeah, I'm tired. Tired brain doesn't do mental math. Tired brain types things in, and that is A-okay, because all I've got to do is what is required to get the marks. So the first value my calculator gives is -pi over 6, which obviously is outside the range. I'm going to use my preferences for cast diagrams rather than graph, although they seem to really want me to be going for graph here. Yeah, they really seem to want me to go for graph here. All right, so it's based on pi over 6. So from the graph, you can kind of see, if I draw on the -1/2, that would cross twice between pi over 2 and pi, and twice between 3 pi over 2 and 2 pi, where that difference is going to be pi over 6. So I would expect it to be, well, that's for the final answer. Am I doing too much? No, it's probably going to be pi over 12. I'll do it two ways. Let me do it my way first. So my way would be from the cast diagram. I'm good working in those. I know that sine is negative, so I'm looking in the T and the C region. I know that the first value is -pi over 6, which is based on an A value of pi over 6, from which I can get my other values. So the T one would be pi plus pi over 6, which would be 7 pi over 6. The C value would be 2 pi minus pi over 6, which would be 11 pi over 6. And I want to keep going up to 4 pi. So this plus 2 pi, which is 12 pi over 6, would be 19 pi over 6. And the final one would be the 11 pi over 6 plus a 12 pi over 6, giving a 23 pi over 6. And then we can divide these all by 2, not including this one because it's not in the interval. So it would be 7. In fact, let me do it on the line below, just so I can. So it's 7 pi over 12, 11 pi over 12, 19 pi over 12, and 23 pi over 12. Now, you could also have done that from this graph by understanding that because this first value was pi over 6, it means that theta would have been pi over 12. So it's based on that. So it would have been pi over 2 plus pi over 12, which gives me the 7 pi over 12. It would have been pi minus pi over 12, which is the 11 pi over 12. and similarly adding pi over 12 to 3 pi over 2 and subtracting pi over 12 from 2 pi. So whether your preference is cast diagrams or graphs, you should be covered by that. Right, now question 5. We have a two-way table, complete the two-way table. Okay, well that's 0.12 to make up that total. That is, this is just the way I know my brain, you got to be able to adjust for your brain in different situations. I know I haven't slept well. I know I just don't have the cognitive load to be doing unnecessary computation. So I'm just going to own that and save my computational power for the problem solving and leave the calculation to the calculator. Because honestly, don't be a hero here. There's no extra points for doing it mentally if that's just going to increase your risk of an execution error. So I'm just going to, yeah. So that's 5A. Complete the two-way table, done. Calculate the probability that an A-level student selected at random does not study chemistry. So I'm just going to write this out kind of in symbol form. So for 5B, find out the probability that they do not study chemistry, given that they do not study math. So given that they do not study math means I'm looking, that means out of these people that don't do math, so out of the 0.58, how many do not do chemistry? That is 0.46. And I can run that. 0.46 divided 0.58 is 23 over 29. Yeah, which I'm just going to leave exact. Now, I also know because my brain is tired, in terms of my exam technique, I know I'm more likely to introduce an execution error, which is why the checking is going to be extra important today. Now, the probability distribution of the discrete random variable x is shown in this table. Calculate the constant a. The syllabus material here is that the sum of the probabilities must be 1. So I know that 0.2 plus a plus 3a plus 0.4 is 1. So 4a plus 0.6 is 1. 4a is 0.4. A is 0.1. Sweet. So a single value of x is chosen at random. Well, what I'm going to do is I'm going to first copy the table back out again with the actual probabilities in it. So that would be 0.2, 0.1, 0.3, 0.4. Now, find the probability that the value is an odd number. So that would be the probability of 1 or 3. So it's 1 or 3, where in probability, or means plus and means times, assuming independent and mutually exclusive. So that is 0.5. 2 independents are chosen. Calculate the probability that the total is 3. All right, so that is the probability of 0, 3, or 1, 2, or 2, 1, or 3, 0. So in other words, it is 0 and 3, or it is 1 and 2, or it is 2 and 1, or it is 3 and 0. Now, of course, I could have just done the 0 and 3 and times 2 for the permutations. That also works as well if you're more comfortable doing that. But this is kind of doing it from first principles. So 0.08 plus 0.03 plus 0.03 plus 0.08. And running that in the calculator because I am good enough to do that in my head. But again, knowing my limits today, that is 0.22. Okay, right. Moving on to section B, where it's going to start to pick up again. So we have a recurrence relationship given here. U2 is going to be equal to U1 plus 5. So it's going to be equal to 3. And we're just going to keep on adding 5. So that's going to be 8, and that's going to be 13. Fair enough. It's right down. Cool. Explain whether this series is convergent or divergent. It is divergent. And explain whether it's divergent because they are not sort of again, I hate wordy questions. Not getting closer to a single value. Or it could be the idea that it's constantly increasing by this at the same rate. So it would increase to infinity. Increasing it steady at constant rate. And it would eventually go off to infinity. Okay. So C, determine the value of U30. Well, I'm just going to convert this into nth term now. So UN is going to be equal to, well, the common difference is 5. So it would be 5n. And when n equals 1, I should get minus 2. So I have to subtract 7 from that. So that means that U30 would be equal to 150 minus 7, which would be 143. I think that's the easiest way around it. Another way you can do that, by the way, is to say that UN is equal to A plus n minus 1d, and say that A is minus 2, n minus 1 here is 29, and d is 5, and that should, it yields you the same answer. So that's another way you could have done that. 7d, determine the sum to 30. Well, we know again that A is equal to minus 2 and d is equal to 5, which means that the sum to 30 is, well, first of all, I'm going to write out the formula first, which I think you'll be able to find in the formula sheet at the top of this paper. Let me just confirm that. Yes, it's in there. Good. So what I'm going to say is that Sn is n over 2 into 2a plus n minus 1d, and then plug in. So the sum to 30 would be equal to 15, which is 30 over 2, into minus 4 plus 29 times 5. Now 29 times 5 is 145, minus 4 is 141, and then multiply that by 15, and we get 2115. Okay, question 8. We have a fun equation of a cubic. Determine the range of values for which it has no stationary values. Well, the stationary value would be when dy dx is equal to 0. So first, we got to take the differential, and we get 6x squared plus 6mx minus 9m. And then the 4 differentiates to 0. And then this thing would be equal to 0. So I'm just going to rewrite that. This thing is equal to 0 for no stationary values. So yeah, I'll write it as I would in the real thing. So for no stationary values. Okay. Then what I would do is, first of all, divide by 3 to make my life easier. Nope, 2mx minus 3m equals 0. And what this means is this quadratic has no solutions to equal 0. Or rather, hold on, I've been unclear. Let me communicate that better. So what that means is this thing would be equal to 0 for stationary values. In general, if dy dx equals 0, you found your stationary values. So that would be true for stationary values. But because there are no stationary values, it means that the quadratic has no solutions. And if it has no solutions for a quadratic, that means we're working with the discriminant. So the discriminant, it means that b squared minus 4ac is less than 0. So that would be 4m squared minus 4 into a into, now not making a sign error, you know that c is equal to minus 3m. This discriminant is less than 0. So 4m squared, 4 times 2 times 3 is 24, and the minus minus cancels to turn into plus. So plus 24m less than 0. So 4m into m plus 6 is less than 0. And I know with quadratic inequalities, the way to do it is to factorize so you can get the 0 values so that you can sketch the graph. So m would be equal to 0, or m would be equal to minus 6. So the graph would look something like this. And we're looking for where this thing is less than 0. So we're looking for this bit in between. So that means that m is between minus 6 and 0. Great. Moving on to question 9. So a teacher is investigating how pupils travel to school each day. Let me zoom out to read the question. Bus, train, car, bike, walk. Sample of 60. The teacher lives in a village 10 miles away from the school. Explain how collecting a sample which just consists of pupils who live in the same village as the teacher might introduce a bias. They might all travel the same way. So for instance, they might all take the same train. Might travel the same way. But also the teacher lives in a village 10 miles from the school. So no one's going to be walking 10 miles. I'm going to see, yeah, no one's walking 10 miles, full stop, the end. So that would certainly favor bus, train, or car. That's the most obvious one, so that's the one I'm going to go with. But there could be things like maybe the village has a very good train line, so a lot of people would be wanting to use that train line. Maybe there's a set bus route. Maybe driving is difficult. Like, it's just, yeah. There's a lot of options I imagine they'll accept there. 9b, the teacher decides to use the method of proportional stratified sampling. Okay. So what that means is you want the sample to have the same proportions as the population. So if we add up all the numbers, so that would be 86 plus 105 plus 107 plus 101 plus 101 is 501. It's 501 students in total, which is a really random number for them to give you, but hey-oh. No, I must have. No. It's 500. Silly goose. That was so close that I was like, no, that's got it. See, that's what today's going to be. You got to check your work for execution errors. Now I went, that was a sense check. I went, something feels off here. I typed in 108 instead of 107. But I just sort of went, no, but that's got to end in a 1. Plus 1 plus 1 is 3. Plus 7 ends in a 0. So yeah. Okay, fixed it. Great. That is the total number of students. So if we want the year 9s, we want the proportion that are year 9s is 107 out of the 500. And we want the sample size of 60 to have that same proportion. And so running that, we find equals 12.84. Now, obviously, you can't have 0.84 of a student, therefore 13 students. In year 9, which I would write, but you know, I'm not going to do that here. The teacher generates a sample of 10 pupils from the 86 in year 7 by listing them in alphabetical order and selecting the first name on the list and every 9th name after. Is that simple random? No, that's systematic. And even then, it's not proper systematic, because for proper systematic, you should generate a random number between 1 and 8, and that person should be your first person. Simple random sample, I'll say no, But I think from the definition, for a simple random sample, every person should have an equal probability of making it, which is not the case here. Is equally likely. Something like that. Or I'll say this is systematic. Maybe that'll get me a mark. Again, I hate the wordy questions, but I'll do my little best. What I will definitely be able to do is question 10. So the first 3 terms of the binomial expansion, right. This is a fractional power, which means I want to use my second year binomial expansion technique. That, again, let's look at the formula book. Make sure it's up there for you guys. Yes, it is. So we want the second one here, which is where n is not an integer or not a positive integer. But this only works when the number is 1. So never forget that. So here, the first thing I'm going to have to do is factorize out 8 to the third. And I would be left with 1 plus, or rather, let me show you both steps in case you don't like this. So that would be in a big bracket. That would be 8 into 1 plus 3 over 8x. And that thing is being raised to the third, which means it's 8 to the third, which is 2. And then it's 1 plus 3/8 x to the third. Now I'm going to move this across because I'm going to need some space here. So that is 2 into 1 plus n thing that's in for x plus n minus 1 all over 2 factorial thing that's second term in the bracket squared. So that is 2 into 1 plus an 8th x minus. Now let's run this. Let me show you what I'm doing. So in fact, this is one of those ones I'm going to bring this across and just show you guys. So that would be a third times minus 2/3 times 3/8 squared, and then divide it by 2. Because 2 factorial is 2, so it's minus 1 over 64x squared. And now multiplying the 2 in, we get 1 plus a quarter x minus 1 over 32x squared plus some other random nonsense. Okay, now for part B, this is only valid when the second term of the expanded bracket, when the modulus of that is less than 1. So we need the modulus of 3/8 x to be less than 1, which means that 3/8 times the modulus of x is less than 1, which means that we will get 8/3. But what it means is that the modulus of x is less than 8/3. And so the range of values would therefore be between minus 8/3 and 8/3. Okay. Now, scrolling back across so that we can get a sense of what's happening here in question 11. So, okay, what's going on here? Householder is investigating whether there's a relationship between his monthly cost of gas and his monthly cost of electricity, both measured in pounds. The householder collects a random sample of monthly costs and presents them in the scatter diagram. One of the points represents the energy costs in a month when the householder was away for 3 weeks. The other points represent the energy costs in a month when the householder did not go away. Circle the point which represents was most likely to have been on holiday. Well, here, because they're not cooking or doing anything, they're not using any utilities. With reference to the diagram, describe the relationship of the cost of the relationship between the cost of gas and the cost of electricity. It's a 1 mark, so I would say positive correlation, but like I'll also qualify that as weak positive. The householder decides to test whether there is evidence to suggest there's an association. They find that the oh, crap. Do I know p-values? I think okay. What you got to do. Oh, good evening. Good evening to you. Good morning for me. I'm assuming that means you're in India. um, so you caught me at the wrong time, man. Getting into like okay, so I know because I know the EdXL one. I know the formula book. I would need to sort of look it up because even with the interesting, okay, because again, this is blind live solve, and so this is also me discovering the differences between the different syllabuses here. I know I can picture the table in the EdXL formula book, right? Where you would look up. But maybe that is the p-value then. No, at the 5% level, okay, let's have a little. Let's have a think about this. Well, because first of all, I'm not sure you have a separate. Well, you must do though, because you need to be able to look up your tables. I'm going to check whether I have all the information here. I'm going to check whether we have. Obviously, if you guys know this board in particular, feel free to drop something in the comments or in the chat. But I'm going to search this up real quick because I have a feeling we should have tables here. So OCR B, MEI, A-level maths formula sheet. Is it just that? Ah, no, you do get a formula booklet. Excellent, excellent, excellent. Okay, so I'm going to download that real quick and bring that across. Oh, actually, to be honest, I'll just drag it. No, I'll download it. It's fine. So it looks like here. So what I know I'm looking for is the tables, the statistical tables, which are usually at the back. Here we go. So what have we got? Oh no, why are you sideways? All right, rotating. So critical values for PMCC versus Spearman rank. They've done Spearman rank. %5 level that there is any association. Well, the alternative is that there's no. So this let me write it out in full. So the null hypothesis is that it is 0. The alternative hypothesis is that it is not 0, which means that it's 2.5% in each tail, which would be positive and negative. So in the booklet, we want to look up 2.5%, or in a two-tailed test, 5%, where n equals. Now, do I want to include this n or not, is the question. I think I don't include this because it's the outlier, which I think is the point of A. So I'm thinking I need to count up how many dots there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I think I'm looking at the association between the 15. So I'll say 15 points, excluding the outlier. It would be helpful if they let me know how they calculated that, whether or not it was included. But for n equals 15, for 5% two-tail tests, it looks like the critical value is 0.5214. I would not be surprised if I was getting this wrong, which is why I am going to mark it up. But I think, and even if I used 16, that would make it even less, but it would still not be beyond that critical value. I'm going to say that 0.4359 is less than 0.5214, therefore insufficient evidence. And then I would restate this in the language of the question. I would say something like there's insufficient evidence that there is an association between the two. Of association. Now, in the syllabuses that I'm used to, don't use this associated p-value. So I'll look up what that means. Apologies for not having that conceptually ready to go. And there's some comments here. So I have a question I wanted to discuss. Can I share it? You have an exam on the 17th. Yeah, feel free to drop it in the chat and I'll get to that at the end. Absolutely no problem there. Right, question 12. A survey conducted in 2021 showed that 10% of British adults were vegetarian. Dietitian believes that the proportion of British adults who are vegetarian may have changed. Okay, so it doesn't say in which direction. That immediately implies two-tail test. So hypothesis test at the 5% level of significance means 2.5% in each tail. So what I'm going to say is we are going to... X is the number of vegetarians. I'm going to say that X is distributed binomially with 112 and a probability, where the null hypothesis is that that probability is 0.1, and the alternative hypothesis is that the probability is not 0.1. So we're going to assume H naught true and say that X is distributed binomially with 112 and 0.10. They find 19. Now, how many would we expect? We would expect 11. So that is above the expectation value, which means this is going to be in the sort of right-tailed region. So here, if I draw a kind of number line situation, it would be between 0 and 112. And there's some line in the sand such that the probability of being beyond that line in the sand is 2.5%. And there's some line in the sand where the probability of being below that is 2.5%. We know that 19 is going to lie closer to that upper value. So what I'm going to do is to calculate the probability of being 19 or bigger. So the probability of X being bigger than or equal to 19. Oh, yes, you posted this question. We will see if I'm smart enough to answer this question in the chat. I will do my absolute level best. Yeah. Okay. We shall see. Your question may have bested me, sir. But what is not going to best me is this. Because I know that probability of X being bigger than or equal to 19, and again, if I show you on a number line, if it's bigger than or equal to 19 included, then it's excluding 18 and below. And on your calculator, the CD only does the less than or equal to. So it's 1 minus the probability that X is less than or equal to 18. So it's 1 minus, and that is where I'm going to use the CD. So it's 112 on a probability of 0.1. So it's 0.9847, which would be 0.0153. That is less than the 0.025 I'm looking for significance. Therefore, reject H naught. And there is sufficient evidence to conclude that the proportion has changed. Because they believes that the proportion, yeah. Can't spell. Evidence to conclude proportion has changed. Okay. Right. So question 13. Determine the coordinates of the turning points of this. Well, this is immediately implicit differentiation, which is just an application of the chain rule. So whenever I see anything with y, I always think d thing dy, dy dx. So in this case, d thing dy, differentiate that with respect to y. You get 2y dy dx. Now this is first d second plus second d first. Differentiate this as normal goes to 2x. Differentiate this as normal goes to -1. 1 differentiates to 0. So we want to determine the coordinates of the turning points of the curve with this equation. So at the turning points, we know that dy dx is equal to 0. And we can plug that in and say that therefore y plus 2x minus 1 equals 0. So y is equal to 1 minus 2x. Now, you absolute chaos gremlins. So that is the condition that is true. But so it has to have that condition met, and it actually has to be on the curve in the first place, which means that's, yeah, 9 marker. Oh, I didn't see that. That's fun. Okay, that's put me in a good mood. All right. So what I'm going to do is I'm now going to plug that back into the original equation so that I can solve them both simultaneously. And that will solve me for the x coordinates, which I can then find the y coordinates for. So y squared plus xy plus x squared minus x equals 1 means 4x squared minus 4x plus 1 minus 2x squared plus x squared minus 1 equals 0. So combining the x squareds, 4 minus 2 is 2, plus 1 is 3. These two cancel, so it's minus 4x. And the minus, those cancel, so it's 0. So we have x into 3x minus 4, and x equals 0, and x is equal to 4/3, which means that y here is equal to 1, and y, by plugging back into here, so 1 minus 8/3, not going to be a hero about it, it's minus 5/3. So those are your 2 points, 0, 1, and 4/3 minus 5/3. Okay, so we found our 2 points. Okay, now going to 14. So we have a box plot, medical data for 103 women and 97 men. Let me zoom out of it so I can see the full question. The weights in kilograms of 101 of the women from the pre-release material. Weird. Why are they excluding the other 2? Using your knowledge of the pre-release material. That's really annoying because that's one thing I definitely don't know. So every syllabus has a different set of data. So in I know for the EdXL, which is my normal syllabus, you're talking about the large data set for weather in 8 locations, 5 in the UK, 3 abroad. That would be May to October of 1987 and 2015. Like there's just a whole bunch of stuff you got to know. So clearly for this syllabus, this is the pre-release material. I'm going to say these were not included because they are I'm going to say 2 not available. Because I know with some of the Excel stuff, it's just not included. So some of the weather data is not is listed in the table as NA. So I'm going to just say it's not included and hope for the best on that. Determine the range of values in which any outliers lie. Okay, so that is, again, done in the Excel. It's certainly done differently, but there is a bit of a standard here, which is Q1 minus 1.5 interquartile range, or it's Q3 plus 1.5 interquartile range. And that's my default I'm working with. I'll see if the OCR is a little bit different. So that's going to be 57.7 minus 1.5 lots of. Now the interquartile range is 82.05 minus the 57.7. And if I pop that into the calculator, I get 82.05 minus 57.7. I get 21.175. And on this one, it would be 82.05 plus 1.5 times that interquartile range. And if I run that in the calculator, I will get obviously a much bigger value of 82.05 minus 57.7. I'm going to get 118.575. So I think the outliers lie in the region of the weight being less than 21.175, which is obviously impossible because you would be dead. Or the weight is bigger than 118.575. Use your knowledge of the pre-release material to explain whether these outliers should be removed from any further analysis. I don't have knowledge of this pre-release material. Whether these outliers should be removed from any further analysis. The data. Well, on the box plot, you're not really, because on a box plot, you're measuring the median and the interquartile range. You're not really that concerned with. Well, it depends on what that analysis is. So if the analysis is calculating the mean, then maybe. And again, this would just be sentence. So what would I say here? This is why you prepare. And also, by the way, what this is showing you, right? So if I'm sort of struggling with something, I understand all of the math perfectly well. So it means that either it's specific to a syllabus, but it's more like the knowledge points rather than the understanding points, which means that these are the sorts of things you can learn like in the sort of last minute. This is the rote knowledge you need right before you walk into an exam room, as opposed to like the core understanding. So whether these outliers should be removed from any further analysis of the data, I would say they won't affect median and IQR. And I would say would affect mean and standard deviation. So remove for those. And D, the median weight was found to be that. Explain what may be inferred by comparing the median weight. So medians. So when you're comparing data sets, there's the measure of the average and there's a measure of the spread. So when you're dealing with mean and interquartile range, if by comparing the medians, you're comparing the average, and by comparing the IQR, you're comparing the spread of them. In this case, the median is found to be bigger. So what might be inferred is that the men on average weigh more. Okay. Because that's the measure of the average that we're using here. Oh, there's another one. Okay, so further analysis is carried out. The table shows some results. Make 2 inferences about the distribution of the weight of men compared with the weights of women. Okay, so this time it's mean and standard deviation. I would say standard deviations are very similar. I would say, hold on. So I'm going to say that the mean is bigger for men. So men weigh more on average. And I would say the standard deviation is very similar. So similar spread, but I have a feeling, actually, I'm wondering if we can do something else with what we got given here. So the median here is less than the mean. Oh yeah, the median here is less than the mean, so that both of them would have positive skew, but that's not compared with the weights of it. So I would say both have positive skew. So the means of both are bigger than the median. Therefore, both have positive skew, which kind of makes sense. There's much more room for you weight to be bigger, but smaller you die. Okay. Didn't like that question so much, but that is fine. I mean, this is why I prefer mechanics to stats. So 15a. Calculate the mean. Well, that's nice and easy. That's going to be 18,535 all over 55, which is 337. Show that the standard deviation is that. Well, that would be the square root of 6,247,066.6 all over 55 minus the 337 squared. If I run that in my calculator, I get 6,247,066.6 all over 55 minus 337 squared. That gets me 3.0. 746. So why am I a tiny bit off here? Huh. Did I type something in wrong? 6,247,066.6 all over 55. Let me, I'm wondering, so what I'm going to do is I'm going to check the mark scheme in a minute. Or rather, not the mark scheme. I'm going to check the formula book in a minute and see whether they're calculating it differently. Are they calculating it differently? So stats, continuous distributions, hypothesis tests, confidence intervals. Here we go. That's correlation regression, expectation variance. Hold on, let me scroll up. Let me just see, because they always have a formula for this. That said, oh, here we go. Oh, they're using 1 over n minus 1. Okay, so they're using a different formula. Interesting. I did not realize the different boards use different formulas. That's going to be really problematic for you if you're on this board using any materials from other boards. Okay, so here. Okay, so simple variance. So sigma squared is going to be 1 over 54 into the sum of the squares which is that big number, 6,247,066.6 minus 18,535 squared all over 55. Okay, so I'm going to run that in my calculator. I'm surprised. I really thought there would be similarities here. 247,066.6 minus 18,535 squared over 55, which is 643 over 45. And then I've got to square root that. And yeah, it's like bang on the money. So it's 3.7801. So yeah, it's 3.78. Why are you out louding? Okay. Great. The teacher or the researcher uses some software to produce a histogram with equal class intervals. Explain why the researcher decides that the normal distribution is a suitable model. It's continuous data. And it is roughly symmetric about the mean. So those are your indicators that that wants to be a normal distribution. Use your answers in A and B. Determine the expected number of bottles which contain Okay, so what are we getting on here? We have the mean, we have the standard deviation, and we normal distribution. Okay, so let's say it's an X is distributed normally with a mean of 337 and a standard deviation of 3.78. So the probability that X is less than 330, if I run that over here, so let's go to distribution, normal CD, lower is minus 9 times 10 to the stupid, upper is 330, mean is 3.3, standard deviation, apologies, is 3.78, and the mean is 337. That gives me, wow, 0.032. Let me just check I got my mean. I mean, like, I got my mean right, surely. 18,535 divided by 55. Yeah. Okay, so that's a very low probability. And then the expectation is that probability times n, which obviously move that 2 decimal points over would be 3 bottles. In order to comply with the new regulations, no more than 1% should contain less than 330. The manufacturer decides to meet the new regulations by adjusting the process. So the mean is increased. The standard deviation is unaltered. Determine the minimum mean volume, which would ensure the new regulations are met. So for this one, we would have X is distributed normally with some new mean and the same standard deviation of 3.78. And we would need the probability of X being less than 330 to equal 0.01 in this limiting case of the minimum mean. This is done using, so whenever you're working out the mean or the standard deviation, that is using the standard normal. So I am going to draw my standard normal curve, which has a mean of 0 and a standard deviation of 1, where z is equal to x minus mu over sigma. Now, what we can do is to do this on a normal curve. So on a normal curve, where would I need to be such that the probability on the left is equal to 0.01? Well, let me set that up. So that would be normal CD, where the lower again is minus 9 times 10 to the stupid. No, sorry, that's not what I want to do. I want to do inverse normal, which is 3. I want the area which points to the left to be 0.01. That is the standard deviation on a standard normal has a standard deviation of 1 and a mean of 0. So that gives me a z value. Well, I'll say, so it's minus 2.326. So therefore, minus 2.326 equals 330 minus mu all over 3.78. And then if I go back into number mode, that thing times 3.78 is that, which means that mu equals 330 plus 8.79, because I'm adding the mu to the cross and I'm adding this guy across, or subtracting this value across. So it's 338.8. I'll call that. Oh, and it says 3 significant figures, so 339 to 3 significant figures. Okay. Did not enjoy. Oh, we're still not done. E, the mean volume of drink is set to be 340. After several weeks, the quality control manager suspects it may have been reduced. So, okay, I'm going to say X is distributed normally with a mean of 340. And we're going to keep the same standard deviation of 3.78. Which means, by the way, that X bar should be distributed normally with same mean of 340, but this time, remember, sigma for 100, sample size of 100, is equal to the old standard deviation all over root n. So over 10, basically. Which gives us a new standard deviation for the sample mean. That's the part that a lot of people forget when doing a normal hypothesis test. The probability, so this would be, well, H naught is that so that's always done on the mean in a normal hypothesis test. The mean is as expected, and H1, the alternative, is that it's reduced. So what we want to do is to calculate the probability of X being less than 339.37, which looks very close. So I really do not think this is going to be significant. But let's see. So here, let's go back to distribution, normal CD. Lower is minus 9 times 10 to the stupid. Nope, that's answer. Don't like that. There. Upper is 339.37. Standard deviation is 0.378. Mean is 340. Oh, wow. 0.478. Now that is significant. Shut me up. That's so close. 0.478. That is less than the 0.5. Therefore, it is sufficient. Therefore, we reject H naught. Sufficient evidence to conclude the mean has reduced. Okay. Now that's one where you would think that it wouldn't be significant, and yet it is. But it's also one that's only significant if you remember to take this new standard deviation of the mean for 100. If you didn't remember to do that, that would not be significant. All right, final 12 marker. This is going to be fun. Fun little way to end a paper. So we have to find the particular integral of the differential equation of stuff. So dy dx is 9y all over stuff. This is separable, so I'm going to say, and I'm going to leave. Am I going to leave the 9? Yeah, I'll leave the line. In general, you want to move as little as possible. So the integral of 1 over y dy equals the integral of 9 over nonsense dx. Left-hand side is obviously ln y. Now, what we're going to have to do is to split this guy out into partial fractions. So, in fact, let me give myself some more room here. So, we've got that 9 over x minus 1 x plus 2 is going to be equal to a over x minus 1 and b over x plus 2. So it's a into x plus 2 and b into x minus 1 is going to be equal to 9. When x is equal to minus 2, we have 9 is equal to minus 3b. So b equals minus 3. And when x is equal to 1, we have that 9 is equal to 3a, which means that a is equal to 3. So therefore, plugging that in, we would have the integral of 1 over y dy is the integral of 3 over x minus 1 by substituting this a equals 3 into here, minus 3 over x plus 2 by substituting the minus 3 in for b here. Now, what that means is that ln y is equal to 3 ln x minus 1 minus 3 ln x plus 2 plus c. I'm starting to get some lag, so I'll save to make sure I don't lose any work. Now we have some particular values to plug in so that we can work out what that plus c is. So we have that ln of 16 is equal to 3 ln 1 minus 3 ln 4 plus c. So that's just equal to 0. So that is equal to minus ln of 64. Using your log laws, that 3 can be taken in and say ln of 4 to the power of 3, and 4 to the power of 3 is 64. So then c is equal to ln 16 plus ln 64, which again, using my log laws, would be the ln of 16 times 64. It would be ln of 1024. So what we have is that ln y equals 3 ln of x minus 1, and it should be the modulus of that, minus 3 ln the modulus of x plus 2, plus the ln of 1024. So that would be the ln of 1024 x minus 1 cubed all over x minus 2 cubed, where that 3 goes up to make that x minus 1 cubed. That 3 goes up here to make it x plus 2 cubed. That's minus, so that goes on the bottom, and these are anything that's added becomes the top of the. It's log laws. It's log laws. If you don't understand that, really practice your log laws because that's important. So if you're adding logs, you multiply the arguments. If you're subtracting logs, you divide the arguments. So that means that y is equal to this monstrosity. I don't even know why. Let me write that properly. So 1024 x minus 1 cubed all over x minus 2 cubed. Now, yeah, I'm going to leave it like that. So that is what y is. Okay. So it looks like I'm done with the paper. Now it's time to start checking. Now, as always, I think checking is the most important. It's going to be a bit harder in the stats where you kind of just have to redo it. I think in the pure, it's much more interesting to think about how to check your work. Here, I think section A is going to be fine. You largely just redo it. I will, as always, show you what I'm doing this time on a check, even if I think it's easy. So going back here, it's the root of 6 minus 2 squared and 1 plus 1 squared, 2 root 5, check. Good. This is a translation. Right, well, what we can do to check this one is we know that this one would go through the point 0, 1. Let's check to make sure the point 0, 1 is transformed in the way I want it to be. So here, where does 0, 1? It should end up 3 units to the right, so it should end up at 3, 2. Let me check that 3, 2. So if I plug in a value of 3, do I get 2? Well, 2e to the 3 minus 3 does give me 2, and so yes, that is correct. 3, to just describe the shape. I don't like words. Determine how many households are in the sample. That's actually nice and easy. So 16 spent between 60 and 65. Let me confirm that 3.2 times the 5. Yep, that is the 16. So it is 0.5 times 10. And 3.2 times 5. And 1.8 times 5. And 1.4 times 10. And 0.2 times 20. So that's 48 total. Great. Question 4, sketch a graph. I did sketch a graph, and I can even confirm that. So let's go into, not there. Let's check that I am in radians. And I'm going to just check I didn't do anything silly there. So I'm going to get pi over 2. And I'm going to confirm that sine of 2 answer does equal 0. Yes, it does. Great. So that is the sketch. As with any trig, let's just plug in my solutions and confirm that they are correct. So if I had 7 pi over 12, I'm going to confirm that sine of 2 answer is minus a half. I'm going to try 11 pi over 12 and confirm that sine of 2 answer is minus a half. I'm going to do, and it is just worth it. Belt and braces. Let's just check it. So sine of 2 answer is minus a half. 23 pi over 12. Sine of 2 answer minus half. So all of those are correct. And I would expect there to be, for sine theta, 2 solutions between 0 and 2 pi. So I would expect 4 solutions for sine of 2 theta between 0 and 2 pi. So I don't think I've missed anything. This one, let me just confirm everything sums up the way it's supposed to. Does equal the 0.36. Checking the second row. That adds up. Checking the first column. Yep, checking the second column. Yep, checking actually just the sum of all of them. Perfect. Okay, so that table is correct. Calculate the probability that the student does not study chemistry given that they do not study math. So out of the 0.58, it is the 0.46. That is just correct. And this is why I say stats is just much harder to check. You just sort of redo the stats. And I'm confident on that 23 over 29. Here, well, we found a equals 0.1. We plug that in. The sum of these probabilities is 1, so that is correct for A. Find the probability that the number is odd. That is 0.5. How do you get the sum total of the two values is 3. That is 0.3. Well, let me just, 0.2 times 0.4 times 2. I'm going to add on to that 2 lots of 0.1 times 0.3. Yeah, 0.22, which does not look like what I wrote, so good. Okay, then into section B again. So it is 3, and then 8, and then 13. So they're, U30, so A plus, in fact, let me confirm it that second way. So it was A plus N minus 1D. 143, good. Determine the value of the sum to 30. That would be 30 over 2 into 2A and N minus 1D. Yeah, that looks good. Okay, so 8 is actually probably going to be a much more interesting check. So first of all, let me check that I differentiated correctly. 6x squared, 6mx minus m. That is correct. Has no stationary values. So I divided by 3 correctly. So b squared minus 4 times a times c, where it is plus. Yeah. I just think this is right. I'm not sure, like, what I would have to do is to select a value in between, plug it in, and confirm it has no solutions. Which I think, I wonder. Is there one where you can solve simultaneous equations? I don't know on this one. I know on the CG50 you could. Oh, no, I don't mean that. I mean just sort of solving it like the equation solver. I'm not sure you can do it on this one. And correct me if I'm wrong on that. But I know on the CG50, for instance, you can type in and you just put like, A equals this, B equals this, C equals this, and it will return what the answers are if there are any answers. But on the whole, I'm kind of okay with how I did this. And so I'm feeling tired and lazy and gonna leave it. Sorry about it. If I get it wrong, it was a sign I should have. I see, even if I make mistakes, they're instructive mistakes. So here, no one's walking 10 miles, so it's biased against that. Let me confirm. Well, no! I press buttons, guys. I shouldn't press buttons. Go back to calculations. I like calculations. Okay, 86 and 105 and 107 and 101 and 101 is 500. We want your 9. So 107 divided by that thing is the proportion times the sample size of 60 we want to find. It is 12.84, which basically is 13 students have to be in that. And then explain something. No, I don't think I shall. This is, okay, 10A is actually an easy. So in other words, okay, let's also talk about this. Let's say you didn't have all of this time to check your answers. There are certain questions which are just better to check than others. And 10A is 100% one that I would check. Because the other ones, I'm like, okay, let me see if I can find a way of checking it. But, okay, so which ones, let's talk about that. So if I were checking it, 2, I would have checked in the way that I did. 4, I would have checked in the way that I did, because I can just plug my answers back into the trig equation. I would not really check 5 or 6 if I was pressed on time, or really 7. or really 8, or really 9, but 10. 10 I would 100% check in any situation because I can plug answers in. Remembering this is only valid for small x's, well, less than 8/3. What we can do is we can plug in x equals 0. I don't know, some random 1, 2, 3, right? Let's plug it in into my expansion. Or rather, let me do 8 plus 3, answer 2 the third. That would be 2.030288973 for x is equal to 0.123. If I redo that, now normally I would plug it in on both sides or rearrange it. So I would do the right-hand side minus the left-hand side and try and get a clean 0. But here, because it's an approximation, I wouldn't get it exactly. So I'm actually going to do this one separately. X minus x squared all over 32. Pretty much bang on the money. You have to get so this expansion feels good. And it's valid for that range that I found, which I feel good about. So I don't have to redo it. I just know that I got it right because I plugged in answers and it worked. This one I was just deeply unconfident on, and I'm not sure that I can actually check my work sufficiently. 12. We're doing a hypothesis test. Again, there's nothing really to do apart from to just do it again. 5%. It may have changed. I think I'm too hungry and tired. If I got it wrong, I apologize. 13 is so checkable. First of all, let me confirm that these points do lie on the line. So 1 squared plus 0 plus 0 minus 0 does equal 1. Great. Now, this y is sufficiently complicated. I'm going to substitute this in using the answer button. So answer squared plus x, answer plus x squared minus x equals 1. Okay, so those points definitely lie on the curve. And are they turning points? Well, d thing dy, dy dx plus first d second plus second d first plus equals 0. Good. If I plug in 0, 1 into here, I get 1. I would get 0, 1. So I would get 2 dy dx. That would go to 0. I would get plus 1. That would be 0. That would be minus 1. So that would cancel. So dy dx would be 0. So that is definitely a stationary point. Now, for a second one, it's going to be a little more complicated. But what I'm going to do is to plug my answers back into this top line and confirm that dy dx would equal 0. So x is 4/3. Y is minus 5/3. So just confirming that. So that would be minus 10/3 y prime plus 4/3 y prime. Now, the rest of it, it would be minus 5/3 for the plus y. We would get a plus 8/3. We would get a minus 1. So that would be nothing. So this thing equals 0, and dy dx does equal 0, so that is also a turning point. So I know with certainty that 13 is correct. 13 would be one that I would check. My criteria, if I'm time pressed for ones to check, is ones where I can do it, like sort of plug it back in without having to rework the whole material. 14, it's not sufficiently interesting for me to check it when I'm this tired and hungry, and I'm not convinced on some of the stat stuff that I got this right for this particular syllabus. So I think the mark scheme will be better help there. 15 is a similar story where I think this is fine. Whereas there's nothing really to check. I mean, I would, again, tired, hungry, sorry about it. Now, 16 is a very good check. So all these pure stuff, basically, the stats is like not that satisfying to check, but the pure absolutely is. So for this, first of all, let me confirm that that actually works. So let me confirm that 10, 20, so if x is equal to 2, then let me confirm that 1024 into answer minus 1 cubed all over answer minus 2 cubed. No, what did I do? Okay, so let me try it again. 2 equals 1024 answer minus 1 cubed answer minus 2 cubed. Why is this a math error? How could that possibly... Oh, yeah. No, that's meant to be a +2. Haha! See, this is why we check our work. Guys, look what I did. So, yeah. There I said x plus 2, and for some reason I changed it to x minus 2. This is why we check our work. I got a math error because I was dividing by 0. This is why we check our work. So you can see it's much more interesting for the pure than it is for the stats in the mech. So take 2, well, take 3 on that. 1024 into answer minus 1 cubed all over answer plus 2 cubed is 16. Okay, so I can confirm that actually does work there. I'm going to plug these numbers back in and confirm I get the same dy dx. So here, 9 times 16 all over 2 minus 1, 2 plus 2, 36. So the gradient should be 36. Let me try and get a dy dx from this and confirm that it is also equal to 36, and then I know I'm right. So here, using the quotient rule, it's bottom, it's bottom d top minus top. Let me just confirm that 1024 times 3, yes, it's 3072, minus top d bottom all over bottom squared. So that is 3072 x plus 2 cubed x minus 1 squared minus 3072 x minus 1 cubed x plus 2 squared all over x plus 2 to the 6. So in other words, it's 3072 into x minus 1 squared all over x plus 2 cubed minus 3072 into x minus 1 cubed all over x plus 2 to the 4. Let me plug in my values of x there and confirm I also get 36, which I think I got before. So x equals 2. Now, wish me luck. 3072 answer minus 1 squared all over answer plus 2 cubed minus 3072 into answer minus 1 cubed all over Answer plus 2 to the 4. 36! It's correct. Okay, so I feel good about that. I have checked. It is mark scheme time. Especially for some of those stats. I'm just so curious. So, boop. Let me scroll to the top. Now, question 1. Let's just quickly blitz this. 2 root 5. 2e to the 3. Yeah, that's correct. Positive skew. Got that right. 48 on B. Yep. That's all good. 7 pi over 12, 11 pi over 12, 19, 23. Yep, that's all good. 0.12, 46. Yep. 23 over 29. Yep. 0.1, 0.5, 0.22. Good. 3, 8, 13. The difference between consecutive terms is not decreasing. Allow a bunch of stuff. Terms are not tending to a finite limit. Terms tend to infinity. Would increase to infinity. I think I would get that. All right, so here, 143. Yep. 21, 15. Yep. Between -6 and 0. Yep. Okay, now this is... Yeah, I know exactly. Must refer to at least one of the given modes of transport. Yeah, no one's walking. Cool. So 13 students is correct. Not simple random because every possible sample does not have an equal probability of being selected. So don't allow systematic. Cool. Allow simple random because every pupil is not equally likely to be selected. That's the one I went for. It does get the mark. But strictly speaking, for simple random, it's not every individual student having an individual, like the probability. It's every sample being equally likely. That's required there. So good to know about the tightness of the wording that they want. Quarter x squared minus 1 over 32. Yep. And yep. So I've selected the outlier correctly. Weak, positive, good. Oh, so it really was just that. Oh, I massively overcomplicated that. For 11C, the p-value was just the probability. Of course, that was so stupid. I should have just, that's the probability. I should have compared that. I didn't think it would be that easy. But yeah, that's bigger than 5%, so it's not significant. Insufficient evidence. All right. Apologies for that. Apologies for misleading you. It was way easier than I made it. My null is correct. My alternative is correct. P is the... I didn't define my probability. I should have done that. I defined my x, but I should have defined my p. So that's probably 1 mark lost there. $19 gives me the correct probability. That is less, so it is, you reject H naught and do make that conclusion. Okay, cool. I did not use critical region. For 13, 0, 1, and 4/3 minus 5/3, good. Not all the data were available. Okay, so I did get the right method for the outliers. So it's Q1 minus 1.5 interquartile range, or Q3 plus 1.5 interquartile range. Did I miss something from the question here, I wonder? So 14B. Did they tell us what the biggest one? Oh, of course. I should have been more explicit that these were, because normally in like the edXL, if you have a tail that does not include outliers, so the outliers could have been on either side of that, but this was actually the full box plot. So anything bigger than 118, yeah. So anything between 118.575 and 132.2 should have been an outlier. I didn't make that explicit. Should have made that explicit. No outliers in lower tail. So apologies for that. Yeah, lack of tightness there, not making good use of the data from the table. So for 14C, should not be removed since no reason to doubt that it's genuine data. I hate that. Guys, this is why I hate the wording in stats. I just do not enjoy it. Typical man is heavier than a typical woman. Allow on average. Yeah. Mean is bigger for men. So distribution for men is located further along the number line. That's so weird. So men weigh more on average. Standard deviations are approximately equal, so similar spread. Yeah, I'll give myself that. 337, got that. Symmetrical, continuous, good. 3 bottles, but I would have got that. Yeah. So 339. And then here, again, okay, so this is something I've got to tighten up when I'm doing my hypothesis testing. I didn't define what I'm testing for. So in the binomial hypothesis test, I have to define the probability. In the normal hypothesis test, I have to define the mean. That is good to know. This is the kind of feedback you pick up in your sort of post-game analysis by going on the mark schemes. You learn what changes you need to make for next time. So we get this thing, which is significant, and we do reject. Good. And then for 16, we get this monster. Love to see it. All right. So from that, I would say that's my main takeaway. So it would be some of the, I didn't get full marks there. The reason why I didn't get full marks is what I just said there about defining the parameter that I'm testing in a hypothesis test, whether it's the probability in binomial or the mean in the normal distribution hypothesis test. I think I lost some stuff from the wording of just some of the stat stuff. So that's something you do. So it's not even so much understanding as much as it is practice, doing lots of stats papers, going through mark schemes, picking up the wording, knowing your large data set, so this pre-release material, and kind of how to analyze that. Knowing the technicalities in stats, like the differences between the different syllabuses. So we saw that when I was calculating the standard deviation, that it was a slightly different formula. So making dead certain you know exactly what formulas you need to use, where to go for them. So even little things like with the Spearman-Rank coefficient, like normally I would expect, I was primed from my training to go to the formula booklet, look up the table, and do that. But they just given me the probability, and all they wanted was to say that's bigger than 5%, so you don't reject. Little things like that come with practice. My conceptual understanding was all there, but in fact, all of that I would say was exam technique rather than even execution. I didn't make so I corrected myself when I in 16, right? So when I was checking, I did make execution errors. Like I changed the sign from x plus 2 to x minus 2, and I caught that by checking. So I showed you that there are some questions that are just better to do your checking on if you have to prioritize certain questions. Lots of algebra, lots of pure stuff, plugging back in a nice, easy way. So that's what I did there on question 16, spotted a little execution error. So if I'm analyzing, if I break out my sort of mistakes, if I split them between conceptual, execution, and exam technique, conceptual, I did fine, apart from maybe you could consider the p-value Spearman-Rank correlation coefficient question. Maybe that was conceptual. Execution errors, didn't make any, because I caught them all because I checked. There was quite a few exam technique issues, defining the terms, that kind of thing. So yeah, that would be my takeaway. That's me analyzing my performance. Those are the sorts of things I would correct for next time and really kind of hold myself to that standard, making sure I don't make those mistakes again on a next paper that I do. Now, back to the chat. So, yes, it is time to take up your question if I can. We do have a common question. It's really complicated. I do not know if I'm going to be able to solve it. We're going to find out. Someone says, can you go through some further math papers in the future? I think I should be able to. I'm less practiced on the further math, so it might be a little bit dodgier just because I think for most students, if you're doing further math, you're not needing tutoring. But I can certainly have a go. There are things like, so it's I'd be fine, but there might be a few wobbles. I think for this exam season, we've only got about 6 weeks left. Next week, I've got the paper 3 one to do. So I don't have a huge timeline left to go through the further math. And I don't know. We'll look at the timing. Maybe I'll sneak in a couple of core pures or something. Now it is time for this monster question. And for this monster question, I am going to go to the Miro whiteboard. So if I just quickly get that up so I can write out what the question was and see if I can have any attempt to grapple with it. It just looked very bitty. So if I can just place it and understand what's happening, I think I should be fine. And if I can't, I'll let you know. If it's just not going to happen, I'm not going to waste your time. So here, if I kind of share my screen and show what's up. So this common question, it was very complicated. So we have to consider 3 sets. So we have E1 is a set. Let me zoom in so that looks a bit thicker. Okay, so we have set E1, which has the elements 1, 2, 3 in it. We have set F1, which has elements 1, 3, 4 in it. And we have set G1, which has elements 2, 3, 4, 5 in it. 2 elements are chosen at random without replacement from the set E1, and let S1 denote the set of those chosen elements. Let E2 equal E1 minus S1. So that's the one that gets left behind. So 2 from here go into S1. And then E2 equals, I'm just going to say leftover, the single leftover. And F2 is F1 unioned with S1. Okay. There's just so many definitions here. Now 2 elements are chosen at random without replacement from the set F2, and let S2 denote those. And let G2 equal G1 unioned with S2. Okay. Finally, 2 elements are chosen at random without replacement from the set G2, and let S3 denote those. And then finally, God, calm down question. You see, this is the JEE Advanced. It's just absolute madness. E3 is E2 unioned with S3. So it's the leftover unioned with this guy. Okay, given that E1 equals E3, let P be the conditional probability. Oh my God. Oh. It's 3 minus 1. Where did I get that wrong? All right, Tisha, I'm relying on you here, man. You got to hold me accountable. If I'm getting something wrong, let me know. It's a 3 minus 1. I don't know where that is. So E1, let P be the conditional probability of the event. S1 has the elements 1, 2 in it. So find that probability. So is the probability of this thing, so we have multiple choice. Is it A, a fifth, B, 3/5, C, a half, D, 2/5? Okay, so let's do some outcomes here. Okay, so E1, let's just do a sort of tree diagram sort of situation. So E1, this would be, so E1 is 1, 2, 3. Okay, so then 2 elements are chosen without replacement from the set E1, and let S1 denote the set. So S1 could equal, it could be 1, 2, it could be 1, 3, it could be 2, 3, with equal probabilities. And in these cases, S1 denote the set of chosen elements. Now, E2 is E1 minus S1. So in this case, E2 would equal the set containing 3. In this case, E2 would have the set containing 2. In this case, E2 has the set containing 1. And I feel like a nice, just systematic approach to this is going to be how to nail this down. F2 is F1. So again, let me lay out what F1 is. 1, 3, 4. And F2 is F1 unioned with S1. So in this case, F2, F1 unioned with S1. So this would be 1, 2, 3, 4. This F2 would be 1, 3, 4. This F2 would be 1, 2, 3, 4. So those are my possible F2s at this point. Okay. F2 equals that. Now, 2 elements are chosen at random without replacement from the set F2. Crap. All right, so we're going to have another tree split. And let S2 denote the set of these chosen elements. Okay, this is going to get complicated because now we got 4. So let me... Okay, but I'm certain about this so far. So in other words, there is a... Let's consolidate this now. So there is a 2/3 chance of F being 1, 2, 3, 4. And there's a 1/3 chance that F2 is 1, 3, 4. Okay, that's what I know so far. So I'm going to refresh from here. So now, 2 elements are chosen at random without replacement, and let S2 denote the set of these chosen elements. So what could I get for S2? So S2 could be... It could be... Well, what I'm going to do is I'm going to do a full tree diagram here. So there is a... So 1, 2, 3, 4, and there's a 2/3 chance of that, and a 1/3 chance of it being 1, 3, 4. And then from here, we have several options for... I have no idea what the timing situation is like here, by the way. I am just doing my little best just to see if I can get there at all. So now two elements are chosen from random from the set F2. Okay, so here we can have 1, 2. We can have 1, 3. We can have 1, 4. We could have 2, 3. We could have 2, 4. We could have 3, 4. And these are what S2 could be. These are all my S2 options. And these would all be equally likely. So these would all be a sixth. So the probabilities of these would all be 2/3 times a sixth, which would be a ninth. So all of these are a ninth of getting up to this point. And then similarly from here, I could get a 1, 3. I could get a 1, 4. I could get a 3, 4, all with equal probabilities, which would also be a ninth. So these are all, and some of these are equal to each other as well. So the 1, 3, 1, 4, and 3, 4 are repeated. So in other words, in total, if I consolidate those, 1, 3, 1, 4, 3, 4 would both become 2. 1, 3, 1, 4, 3, 4. Okay, so this is the full probability distribution for what S2 is allowed to be. Okay, now let G1. So now we know that G2 is G1 unioned with S2. So we know that G1, what did we know that G1 was? G1 was 2, 3, 4, 5. So we can now get all the possibilities for G2. So the G2 could be, so it's G1, G2 is this guy unioned with S2. So G2 could be 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Or it could be 2, 3, 4, 5. As in there and there and there. Okay, so with what probability is it this? 1, 2, 3, 4, 5. So this will happen 5/9 of the time. This will happen 4/9 of the time. So we know what the distributions are for G2. Cool. Finally, two elements are chosen at random without replacement from the set G2 and let S3 denote the set of these chosen elements. God damn it. So we can, in theory, get what the S3s are. And let E3 be E2 unioned with these S3s. Now, this is going to get complicated because 5 choose 2 is 10 possibilities. There's 10 pairs I can get from this. And 6 pairs I can get from that. And they would consolidate, but I would still get 10 possibilities. I'm disinclined. Well, hold on. So you would get 5/9, 4/9. So you would get 10 possibilities there, each of probability an 18th. And 6 possibilities from there, each with probability 2/18. No, that's not right. So 5/9 over 10. So so it's 10 lots of 1 over 18. Oh, and then each of these would have a probability 2 over 27. So all the duplicates, so any of the ones with a 1 in it has a 1 in 18th. So all of the, so one paired with, you can have one paired with 2, one paired with 3, one with 4, one with 5. And each of these have a probability of 1 over 18 of showing up. And then 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, and 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each of these would have a probability of the 1 over 18th plus 2 over 27 of showing up. I'm just going to run that on my calculator. Now, is there a faster way to do this if you're trained on it? Possibly. I'm not trained in this paper. This is just a blind solve. So each of these has a possibility of 7 over 54. Now, let me confirm that 4 over 18 plus 6 lots of 7 over 54 does equal 1. It does. Okay, cool. These are all the possibilities for S3 with their probabilities. Now, those are all the possibilities at S3. And then let E3 equal E2. What the hell was even E2? S2, where's E2? Oh, E2 is the element left behind. Oh, crap. So I consolidated these. No. I may have screwed this entire thing, not knowing I had to come back to this. But basically, you're tacking on a 3 or a 2 or a 1. This paper, man. Because I thought I could consolidate that into 2/3. I wonder if it loops through. Does it matter? Maybe it doesn't matter. Maybe I shouldn't have fed those through. So E3 is E2, and then you tack on. Man, I think I messed that up. Given that E1 equals E3. Well, maybe I should have considered the given that first. Given that E1 equals E3, where E3 is what happens if I tack on the remainder to S3. Oh, man, this is so tricky. So tricky. Okay, so let me try this. Let me try something different. Let me start with the given, because I think maybe working forwards was not the plan. I think, because we can eliminate automatically anything with a 4 or 5 in it. Maybe I could have done this simpler. So let me go through what my process was. So I started here, I got a pair. I tacked that on with this. And then I took pairs from these. I smushed them in with this, and then took pairs from that. And then S3, I tack it on. But am I going to find E3 though? Or is it going to be, but it says given that E1 equals E3. So you can start there. So it's out of that. Be the conditional probability of event S1 being the 1, 2. So what are the chances? So given that E1 equals E3, what's the probability that I came from there? So I think I did cause an issue by consolidating these, I think. Oh, no, this is fine. Because that was 2/3. All right, try writing E3, you'll see. Okay. All right. So ES3 is that. Well, the problem that I'm having here, though, is I can't remember, like, the E2s were the ones that were left behind, but not all. Some of these There's a reason why I'm hesitant there, and it's because I didn't keep track of what E2 was for each situation. So I just took these two F2s, combined them into a single one with a probability of 2/3. But in some of those cases, E2 was 3, and in some of those cases, E2 was 1, and I didn't keep track of which was which. Then I also consolidated them with these guys up here. Like, I did too much consolidation, I think. Or rather, hold on, let's say what would have happened if I hadn't done that consolidation. In that case, they would have had a 6, each 6, 6, and 3. 6, 6, and 3 is 15. Each of them would have a, let me just check that. 6 and 6 and 3 would have each been 1/15th probability of going through like that. And then consolidating it with that. Nope, it's fine to consolidate. Okay, I'll take, do you know what? I'm just going to take your word on it. So consolidate. Okay, so we have these with these probabilities. And then let E3 equal E2 unioned with it. I'm still not convinced, logically speaking, but I'll take your word for it. So E2, I don't buy it. I don't buy it. What's the probability that it came through S1 being 1, 2? Well, hold on a minute. If that is true, then it's sort of the probability that we have to tack on E2 is 3. But you see, that could have happened with the 1, 3. My brain, it's after the end of a 2-hour. Okay, because what, here's the thing. I could take an overview of the overall process till we reach E3, it's Bayes' theorems question. I just think I'm not on form right now to get that. I think it's a stretch question for me. I may not be the one. I've got some brain power, but not unlimited. Because I know what you mean by Bayes' theorem. That's the probability of A given B. Oh no, maybe I don't. It's been a while since I've done Bayes' theorem. Not gonna lie. Yeah, I think this is where you lose me. I can have another attempt. Maybe this would be one where I have to sit down and do it on paper, but I think as a live solve, I don't think you're going to get that fluently. Like in a paper, I would be kind of screwed here. But it's just bananas, because this is what I think you would have to do thus far. And I think just, yeah, you're gonna need a proper pure mathematician to walk you through the rest of it. Today is not the day. That was my best for a first attempt, is what I'll say. But yeah, that question is absolutely insane. Hold on. Okay, so well, you say that. You say I used it earlier. Because to me, this isn't Bayes' theorem. To me, Bayes' theorem is about the knots. So if we're going to take your logic, but the problem I have, though, so, okay, so consolidating that, the problem is, here's my problem, right? Okay, so I know, okay, here's the issue I have. So when we're forming E3, we're going to union it with E2. But the problem is E2 was locked in at some point earlier on in this process. So I can't take something which had an E2 of 2 and union that with something that had an E2 of 3. I think they have to be separated. Because, for instance, okay, so we're trying to find the probability that we came from S1 being 1, 2. That means we're trying to find the probability of E2 being 3. Oh, wait, no, I do see your point. I do see your point. No, no, no. Okay, what I was missing there is the fact that it has to be equal to E1, which means it has to be equal to 1, 2, 3. And these were all pairs. Okay, that's what I'm missing. These were all pairs. And so for it to work at all, these have to tack on with the remaining one that's different to form it. So in other words, this would be the only way to make S1 equal to S3. So out of all the possibilities is if I take this 1, 2 and add a 3 to it. So that would be 1/18 times a third. And if I added on the 1, 3, which is an 18th, times a third to add the 2 into it. And if I took the 2, 3, which is 7 out of 54, and the 1 in 3 chance of adding a 1 to it, and then work out the probability that it came from adding a 3 in, which would have been this 1/18 times a third. Let's multiply top and bottom by 3. Looks like it's that. Let's multiply top and bottom by 18. No, I'm no, I'm not overcomplicated. Yeah. You would get 1 over 1 plus 1 plus 7 over 54 times 18 is 7 over 3. So it's 1 over 3, 6, 13 over 3. Yeah, that would be 3 over 13, which is not an option. And that's the reason why is because I think we consolidated, which isn't what you're supposed to do. Oh, consolidation is a must in the real exam. You don't have enough rough space. Just think of your whole process till you reach E3. You can do it from there. I think I probably could do it if I'd had any food today, any sleep today. The solution is a fifth. I don't know. Yeah, something just went off there. Something just went off there. But like, I don't know. That's you're getting my level. You're getting my level. So I'm much more of a science guy, to be honest. Like once you get that deep into the math, I think I would not do well in a JEE advanced. Like you've well done. You've stretched my limit, but that's not it. That's because you get this idea right now. It's a totally legit thing. There's a difference between science brain and math brain, and I very much have science brain. I'm like, let me poke it and see how it moves. But then with this, I'm like, but there are too many possibilities. Yeah, in the real thing, that's just getting skipped or guessed. No, they have negative marking, so you can't guess in the JEE Advanced. It's bananas. In other words, if nothing else, then what I've done for the last 25 minutes has been to confirm that that is outstandingly difficult and that a reasonable person cannot be expected to just jump in and get that. That's wild. That's just wild. So yeah. 3 hour paper, 54 questions, just bananas. And going back, okay, someone did ask, could you please make a video on how to tackle the hard probability questions? Maybe. Okay. So the hard probability questions, including Venn diagrams and probability trees. Yeah, okay. So thank you for that. I'm going to go. I'm going to eat, because if I haven't mentioned it 12 times today, I'm very, very hungry. PCMO covered. Okay, so I'm going to leave it there. Although I do, let me put this way, I'm never mad at you dropping something. No. I was literally going to preempt this. Do not worry. Like, drop things in the chat. I'm going to have a go at it, because even if I can't do it, it's still instructive. Like how, because I'm putting myself in your shoes where I'm like, I don't have a clue how I'm going to solve this. Like, what's my method? And kind of show how to sort of move through the steps. Even if I don't find a solution, I think there's something to be learned in the process. So never apologize. Always feel like you can drop your questions in the chat and I'll try and get around to them. But in the meantime, I will probably set up another stream for Friday to go through the next physics. And then the final live solve of this series should be at some point next week at a time that I shall announce. In the meantime, keep revising, work real hard, get good results. Take care. I'll see you guys next time. No worries. All right. Take care. Thanks. Glad it helped. Bye-bye.